So now we'll have a closer look at the analysis we just did of the nickel, gold, nickel sandwich samples, where we determined the start death and the end death for the three samples we had. Start death, end death here for sandwich 1, we deposited more nickel on top and it moved downwards to 10 to 20, deposited more nickel on top, and the layer moved down to 25 to 35. So very simple, it's buried deeper and deeper. The gold atoms is buried deeper and deeper in the nickel structure. If we take the thickness of this is x2 minus x1, we get 13, 12.3, 10.3. We also determine the concentration in these layers. It was 0.8, it was 0.67, it was 0.5. So if we multiply the thickness by the concentration, we get what we call the amount of substance of gold atoms we have in total in these samples. They turn out to be 10.4, 8.2, and 5.2 angstroms. Now this, we would expect that to be a constant actually, because it's the same gold atoms we're looking at. So no gold atoms are going to disappear from the sample as we deposit nickel on top. That's very unlikely. And but if we now try to make a correction of these for angular deflection, we can use this simple idea we have in the CF factor here. So we have these three concentration at these three depths. So if we take the mean depth here, that's about 6 angstroms and 15 and 30 angstroms. So we have that here. This is the mean depth for the three samples, the mean depth of the gold layer. If we express that in units of lambda, which is what is done here, right? Well, and lambda is 13.7 angstroms, we get these numbers. So if we look up here, we have a correction factor that is about 1.1 for the first one here at 0.5. It's about 0.85 if we go to 1.2 here. 1.2 is about here, and that's 0.85, about 1.85. And for sandwich 3, we are at 2.2, so that's here, and we are about 0.6. Now, if we divide the amount of substance by CF to correct for angular deflection, we then end up with 9.5 angstroms, 9.7 angstroms, and 8.7 angstroms. Very constant. So you see, this is a very simple way, but a very efficient way to correct for elastic electron scattering.